So if we want to create confidence intervals using the t-distribution to approximate the mean where we don't know sigma, we essentially have 5 steps, where we first verify that sigma is unknown and that we can use the central limit theorem. Then we find our sample statistics, x bar and s. Sometimes they'll be given, sometimes we'll have to compute them. Then we identify the degrees of freedom, level of confidence, and critical values, our 3 big pieces. Find the margin of error using them, and find the endpoints of the interval, where I will say that this is the step-by-step approach, and I'll go through one example with the step-by-step approach. But truthfully, at this point, I'm hoping you've gotten comfortable with the calculator, because this is the point where we're going to see that getting good with the calculator, being good with the calculator, will be far more efficient than going by hand. But anyway, we're going to get an example here where we can see what it looks like if we want to do this kind of the long way, as well as how the calculator would handle it. So for this example, we have that a college admissions director wishes to estimate the mean age of all students currently enrolled. The random sample of 20 students has a mean age of 22.9 years with a standard deviation of 1.5 years, and the population is normally distributed. Construct a 90% confidence interval of the population mean age. So here, the first thing you have to be careful of is seeing that they don't tell us anything about sigma. They don't tell us that sigma is equal to 1.5. They tell us that 1.5 is the mean of that sample with 20 students. So we don't know sigma, but because we're working without that value and we have a suitably sized sample, we get into that sort of side case with the central limit theorem because of the approximation of normality here that we're kind of assuming. So we're good on the first step. The first step's not really big in terms of computation or working on anything. It's just checking the details are the details we want them to be. From there, we just identify what pieces we do have, where we notice that in this case, x bar is equal to 22.9. S here is equal to 1.5, and then from there we have a little bit more. So since n is equal to 20, that means our degrees of freedom are 20 minus 1, or 19. And then because we want to deal with a 90% confidence interval in this case, whether we're going to use the table here or the inverse t function in the calculator, we run that value there, and we will get that our t critical value in this case is approximately 1.729. So now we have all of the pieces we need. We can go ahead with getting our margin of error, the value e, where here e is equal to our critical value, just like before, multiplied by something like a standard error, s over the square root of n. And as a result, this will have form 1.729 multiplied by 1.5 over the square root of 20, or approximately 0.6. And then from there, to get our interval, we make our interval in terms of the value x bar, in terms of our point estimate. So that's going to be x bar minus e to x bar plus e, where here that takes the form 22.9 minus 0.6. Let's be careful with that. We're not stopping there. Up to 22.9 plus 0.6. And push those in, pull them out. We get that our 90% confidence interval in this case is 22.3 to 23 23.5, approximately. Where if we want to double check this, if we want to get our value a little bit quicker without going all the way through by hand, as it were, although we still needed some calculator work anyway, we could use the t-interval computation in the calculator where we would have to plug in these same sort of statistics, these same sort of values here in terms of n and x bar and s, but especially considering you have to get stuff in the calculator usually if you want to get the critical value for the t-score, you might as well learn t-interval as well anyway, because it gets you here a bit faster. Though there is one thing I should say, just to be careful with this, that we could say with 90% confidence our mean is between 22.3 and 23.5, but this doesn't quite imply that the mean is in that range with a 90% probability. What it means is something more along the lines of we would expect 90% of appropriately drawn intervals like this, that is, intervals drawn from the same sort of sample, to contain the mean. Although, realistically, in practice, we do take it to mean something close to what that former thing says. But anyway, this is the general approach for dealing with confidence intervals and t-scores, but we'll get one more example here where, for reasons that'll be clear from context, I'm not going to go through all of these steps again in detail, but we'll at least see how it's done.